All right, try this again. Class. Tree. Give me a shout out for your homies back in, you know, in Vietnamese. No. Wow. What? Man, what the hell? Man, why did every get so dark? Anyway, so going with this first derivative test, we're dealing with a lot of parabolas, and so again, we're going to be throwing up gang signs. So I'll show you. So okay. There's one gang sign. I'm going to throw up the other gang sign. Wow, my fists look horrible. And then here's my other gang sides. So, this one is concave up. In concave up, right here, if it's a parabola, that means right here, that would be the vertex of a parabola, right? And in that parabola, that would be the minimum. Perfect. Minimum. Yeah. In this one, for this parabola right here, it would be a minimum. So that would be a point where my derivative is equal to 0. Good. Okay, so now my my special hand, okay, we just refer to as my special hand over here. So same thing goes through here. This would be concave down. Okay, so concave down, throwing up that gang sign. That means that this right here is going to be maximum, right? Again, my derivative is going to be equal to 0 there. So that's going to be talking about our concavity. So when we're actually doing these, yes, I'm going to be throwing up some gang sign here for you. But yeah, hopefully my drawing gets better. Now, here's the verbiage for this. Let f be a function that is continuous on an interval. Suppose that c is a critical number of f and a to b is an open interval in I containing c. I mean, c is somewhere in between a and b. If f prime is greater than 0 for a less than x less than c, and f prime is less than 0 for c less than x less than b, then it is a local maximum value. So, watch this. Here's the number line. I'm going to call this c. If this right here is positive, and this one here is negative, what do you think is happening? So if this is for my f prime, if I have a positive derivative there, that means it's going up, right? And if I have a negative derivative there, that means after that point it is going down. So therefore I have right here, okay? It goes up to my maximum and then goes down. See? Throwing up those gang signs. Yeah. Next one, f prime less than 0, blah, blah, blah. Okay, so again, for this next thing, it's going to look like this of c, and this is my negative, and it changes to a positive here of my f prime. So, negative to a positive. So that means, so if I'm throwing up the sign right here, it goes negative down, right? Positive. So that means that right there in my gang sign, that's going to be my minimum. If f prime has the same sign both signs, then it's neither a local minimum nor a local maximum. This happens when I have like a x cubed which gives me something right here. This would be a C, where over here, this slope would be positive, and this slope over here is also positive. Positive. Right? Positive, positive. So that's what that means. So it's neither. Okay? Okay, C is critical number of F, and F is increasing on the left of C and decreasing on the right of C. F of C is the local maximum value. F is decreasing on the left and C is increasing on the right, then C is a local minimum value. Now, why are they using the words local on these ones? Go ahead.
Because the graph can keep increasing or decreasing.
Yep.
There.
Yeah, so the graph to the right increases to infinity, and to the left it goes to negative infinity. So therefore, so if it changed from increasing to decreasing, right here, throwing up that gang sign right there, so that's going to be a maximum there. Okay, over here, throwing up that gang sign, so decreasing, increasing. Wait, come on, come on. Ah, there we go. So for those people watching at home, I am doing shadow puppetry. So yeah, so that's my gang sign right there at the bottom. Find the local extrema of this. So, first thing I'm going to do, if I'm looking for local extrema, that means that I need to first find the derivative equal to 0. Are you writing yourself a note for that? To find this, my first step is derivative equals 0, right? Okay, good. So, we have f prime of x is going to be equal to 4x cubed minus 12x squared. Yes, no, maybe? Okay. So now, okay, I'm looking at that problem and you guys are all just saying, F that. Pa-da-ting. Factor it, right? Ah, see what I did there? See what I did? Factor is an F word, right? Okay. So, 0 equals 4x squared quantity x minus 3. Okay. And thanks to my zero product rule, anything times 0 is 0. So this right here is going to help me out. So x equals 0, right? And for this part right, come on, this part right here, x equals positive 3. So now I have two places, I have two critical numbers now. So I'm going to make a number line. So I did this, I got my critical numbers. My number line is going to consist of 0 and 3. And so I'm going to look at numbers in between my critical numbers. So let's start with, and I'm going to start by plugging in to right here. Because I want to know what the slope is, and the slope always has to get into my derivative, right? The derivative gives me the slope. So I'm going to plug in critical numbers into this. And that's going to tell me what my slope is. So now let's start with negative 1. So if I do negative 1, so negative 1, this is going to give me negative 4, right? Right? And if I do negative 1 over here, it becomes positive 1. So that's going to be 4. So I have a positive and a negative, which gives me a negative. All right, let's find another number. Let's do positive 1. So positive 1 is going to give me a negative 2 and a positive 4 out here. So together that's also a negative. And let's go with 4, because why not? So if I plug in 4, I get a positive 1. Plug in 4, I get 16 times 4 is 64. So it's positive, positive. So therefore, on this side, it is positive. So now, what do we know what's happening at 0? Yeah. So therefore, it's just stepping down. It goes to a critical point and then goes back down. It's like that x cubed. And then, what happens at 3? It goes back up, right? That gives me a positive. So therefore, my graph, if I were to sketch my graph right here, pick another point. So it's going to go down to 0, down again to 3, and at 3, it goes back up. And that's sketching because, there you go, like that. If I have to sketch with this information, those are the things that you're going to have to understand. All right, I know it's going down, so it's going down this way, right? It tops off. I have a slope of 0 right here, and it goes back down right there. Bam. So some of your problems are actually going to ask you to sketch using this information. Make sense? Good. Find the local extrema of this. All right, same steps. So start by finding the derivative, and I can use product rule, or I could just distribute. This one's a simple one. I could distribute this, right? Yeah, so wouldn't this one over here be 3 over 3? X to the 3 over 3? Christian, do you agree? You're giving me that crazy look right now. That one right there. So distribute, so it's going to be, so f of x is going to be x to the 5/3. Yes? Minus 5x 2/3. Do the derivative, so f prime of x is 5/3 x to the positive 2/3 minus 10/3 x to the negative 1/3. Could have swore I was helping someone's homework problem that was like this yesterday. Yeah? Okay. Set it equal to 0, and let's take care of that negative exponent. I'm going to bring the negative exponent, so I'm going to rewrite it so it's going to be a little bit easier to see. So I'm going to have 0 equals 5x 2/3 over 3 minus 10 over 3x to the positive 1/3 Are we good still? Kinda? Okay. Alright, I'm going to multiply because I need common denominators. So I'm going to multiply this first one here by x to the 1/3 over x to the 1/3 because they both already got a 3, right? So I get 0 equals, that's an equal sign there, 5x Juju? Are you okay there? Hopefully that wasn't too crazy. Now, zero product rule. What am I going to do to both sides? Multiply everything by 3 x to the 1/3. But before that, now that I see this right here, do I have any restrictions here? I do. What can I not have? Cannot have 0, right? X cannot be 0 because that's going to give me undefined. So that's a critical point. Multiply both sides by 3x to the 1/3. And so that's going to give me 0 equals 5x minus 10. So therefore, x equals what? 2. So x equals 2. So I have two critical numbers. Two critical numbers. One where my derivative is going to be undefined, and the other one is where it should be equal to 0. So, number line this. And we're going to plug them in right over here. So we're plugging them into this to make life easier, because I'm just evaluating my slopes. So if I start with -1, what is the cube root of -1? -1, right? So I'm allowed to have a cube root of -1, so that would be -1 times 3. That's a -3 in the bottom. I have -1 times 5 is -5. -5 minus 10 is -15. So the top of my function is going to be negative. The bottom of my function is going to be negative. And two negatives make a positive. So over here on the left, this is, at -1, I had positive. Let's do another one at +1. At +1. Cube root of +1 is 1. Times 3 is 3. So 5 times 1 is 5. Minus 10, -5. So I have negative over a positive is a negative. And I'm going to pick 3, because why not? Cube root of 3 is still cube root of 3, right? So is that a positive or a negative? It's still going to be a positive, right? So in the bottom, still going to be a positive. And 5 times 3 is 15. 15 minus 10 is 5. That's a positive. So positive, positive is going to give me a positive over here. So I'm going to try and sketch a graph for what this is going to look like. It's positive, negative. So that means right here, so positive to negative here. And at 2, it goes here, and then it goes back up. So right here and right here. Come on. There you go. So by sketching the graph, that's what it's going to look like. It's not too bad, is it? No? Maybe? Huh?
0 is an asymptote.
0 what?
0 is an asymptote.
No, this is, so if I look right here, this is the function, right?
Oh, okay, never mind.
Yeah.
No, see.
We're just talking about the derivative is undefined.
Yeah, I got it.
So that makes it critical.
I got it.
All right, there we go. So, guess what? I'm gonna leave off here. We're gonna pick this up tomorrow. So make sure everyone likes, shares, subscribes, hit that notification button, and support my channel. And I still have a channel, cause yeah, and I still have that merch store. I tried canceling it, they didn't let me. They charge me and they won't refund me. So I'm like, ah, damn it, have to have one more year. Okay,